Alright everyone, today's lesson is lesson 2-6, which hopefully by the end of this you will be able to know the learning targets. I know the Pythagorean Theorem, I know the triangle angle sum theorem, and I know the circumference and area of a circle formulas. Now these three formulas are ones that we've used before, so it would just be a kind of review, but as we know from the book, it takes what we already know and expands it onto some more difficult situations. So just as a refresher, I want you to brush up on these three formulas and theorems. First one that we need to talk about is the Pythagorean Theorem, which the definition says the formal definition says the square of the hypotenuse of a right triangle is equal to the sum of the squares of the other two sides. Now, what does that mean? Well, taking a look at this graphic here, if we take the square of the hypotenuse, so I take C, the hypotenuse, and multiply it by C, I get this entire area of this red square here. This entire thing is equal to the sum of the squares of the other two sides. So if I take A here on this side and multiply it by A, I get this square here. And if I do B times B, I get this square here. Now, if you add up the number of squares in this blue square plus the number of squares in this green square, it will equal the number of squares in the red square, which actually illustrates one of the most famous Pythagorean triples, it's called. Basically, is the grouping of numbers together that follows the Pythagorean theorem, is 3 squared plus 4 squared is equal to 5 squared, which generically there's plenty of situations and numbers that follow the formula a squared plus b squared, which is equal to c squared, which is your basic Pythagorean theorem. Just a quick refresher, again, if you know what a is and you know what b is, so you know that a is equal to 3 and you know that b is equal to 4, you would follow PEMDAS in order to figure out what c is actually equal to. So you do 3 squared, which is 9, plus 4 squared, which is equal to 16. Using the E version of PEMDAS first, and then you would add them together, so 9 plus 16 is equal to 25. In order to get rid of a square, because again we just want the side length, we don't want c squared, we want just c, we always take the square root in order to get rid of the square, so then we would take the square root of 25, which we know to be 5, which I've already said for the Pythagorean triple. Just a kind of a cool water demonstration found on YouTube. So I'm going to show you that here in just a second. Let me pull it up here. I'm actually unable to put it at full screen, but here's still a representation of the video. So as you can see, there's actually water and it's food coloring to show you that it's actually, but again, we have the small square plus the medium-sized square, and as the water is actually filling up, it fills up perfectly to the actual square itself there. So that's kind of a water demonstration of that formula in action. And if she splits it to the other way, obviously the opposite is true as well, where c squared is equal to a squared plus b squared there. Moving back to our PowerPoint, the second theorem that I want you to realize again is the triangle angle sum theorem, which states, and I would probably put this in your notes because this will become important, really important as we move along, but the sum of the angles of a triangle is 180 degrees, and we've already talked about this in class because basically, and again, if you look at it, you have and we're going to kind of explain why here later on, but you have 65 degrees here and you have 30 degrees here, and we'll figure this out later, but this 30 degrees will match up with B and 65 degrees will match up with A, which then, as we've learned, a straight line, if you think about your protractor, from one end to the other is 180 degrees. And so we'll do an experiment here in class, hopefully if I have time, that then will demonstrate this, or at least help us also find a different version for it too. So what I would like you to do for your actual kind of homework for the notes today is I'd like you to actually tell me what x is equal to. So I'm going to come around tomorrow and I just want you to be able to tell me what is this value here, knowing and using the triangle angle sum theorem. So again, have that in your notes please for me, so solve that. The third theorem that we're going to be dealing with, or formula, is basically two different types of circles, or two circle formulas that we're going to use. If the diameter of a circle is d, as we know here diameter is all the way straight across, then the circumference is equal to pi times diameter, or well, as you can see here, but basically also know that diameter is twice as big as the radius. So if we also took 2 times the radius and multiplied it by pi, that would also give us the same thing. But our formula today, we'll use circumference is equal to pi times d. And as you can see, I guess I have that in the way, but if you basically take and roll out the circle, okay, that has a length of 1, or a diameter of 1, it rolls out to be actually 3.14159 whatever. So again, the diameter is equal to 1, and so then the circumference will then be equal to pi. So I guess I didn't realize that I had that on there, but hopefully you can be able to see it through there. And last but not least, two circles of our two circle theorems. If the radius of a circle is r, then its area is pi r squared. Now again, if you take a circle and I keep splitting it up into different pi chunks, and actually if I split it up and I chunk it up into even smaller pieces, this shape right here will start to form a parallelogram, which we should know from previous times that parallelograms are, the area of a parallelogram is equal to the base times the height, and so if our base is the basically distance of halfway around the circle using our circumference, so not 2 times pi r but just pi r, and our radius is also our height here, if I do pi r times r, well that would be r times r, which is r squared. And if I remember, I will also tell you kind of my little trick for this in class tomorrow to kind of remember area. But again, you need to know circumference and you need to know area for me. And last but not least, what I want you to do is I would like you to tell me what is the exact value for the area and circumference of the circle to the right. So previously in pre-algebra, I would just say, okay, find me the value of the area and circumference using pi is equal to 3.14. Now I don't want you to do that. I want you to actually tell me what is the exact value of the area of the circle and the circumference exactly of this circle as well, leaving it in what I call in terms of pi. So pi should actually be part of your answer, where you have basically, I don't want you to multiply by pi. I want you to just leave it as it is, as the symbol, kind of like a variable, but just leaving it there. We're going to talk about that here a little bit later, but this will become important once we get to our actual proficiencies itself. So that is it. That is all I have for you. So again, make sure that you get those couple things. Make sure you get the triangle angle sum example and also this circle example as well, trying to figure out what is the exact area and the exact circumference of it. Thanks for listening, and I will talk to you next class period.